Hello, in today's video we got a Chevy Cobalt with a random cylinder misfire. As it warms up it tends to misfire a little bit more. I've got the vehicle idling right now, and you'll notice that at first the current misfires will be few, but as it idles longer it'll be more frequent. These random misfires are more difficult to pinpoint due to the fact that when you run tests on any of the sensors, coils, modules, or any other components, the readings you'll usually get will come back as if there's nothing wrong. When it comes to random cylinder misfires, you'll want to look at correlations to the cylinders that are affected, which in this case you'll want to look for things that can affect all the cylinders. Anything after this mass airflow sensor can affect the drivability, because the sensor detects a certain amount of air coming in, and a leak behind the sensor is basically airflow that's unaccounted for. So what you're looking for or listening for are any leaks between where this intake manifold meets the cylinder head and the mass airflow sensor. So things like the throttle body and any lines that are attached to the throttle body or the intake manifold. Luckily, this vehicle doesn't have much of any vacuum lines. The only vacuum lines I noticed on this vehicle are this evap tube and this hose that attaches to the brake booster. But what I mean by listening for any vacuum leaks is that you can normally hear them. A small leak will come off as a whistle, while a larger leak will come off more as a suction noise. Another thing I check is how this oxygen sensor is operating. This oxygen sensor is very important in relaying information to the computer on how the engine is running, and the computer uses that information to adjust the way it runs. So an oxygen sensor that's not working properly can definitely cause a misfire. So what I do is connect my scanner to monitor the operation of the sensor, making sure it's operating within specs and giving a proper reading. You'll also want to check your fuel pressure and make sure that your fuel pressure is steady, which I got a video on that I'll link up on top and I'll put in the description. This video will show you what bad fuel pressure looks like, and it'll also show you what proper fuel pressure looks like. That way I avoid making this video too long. Well, now that I got all the engine running tests out of the way, I continue with the basics. Now I want to look at the spark plugs and the condition of them. See if they've been replaced recently and how the tip looks. A spark plug tip can tell you a lot about how well the engine is running. It'll tell you if it's running rich, lean, or if it's burning oil, and so much more. When removing the spark plug wires, or the coil boot assembly in this case, you want to make sure that the boots do not have any oil soaking them, because that would definitely cause a misfire, and tell you that your spark plug tube seals are leaking, but not so in this case. So what I would do now is remove a spark plug using a 5/8 spark plug socket and extension so I could check the condition of them. I was told that they just recently replaced these spark plugs trying to fix the problem, and it does look like they are pretty new. Judging based on the tip, there's no sign of anything obvious here yet. Next, I'll go ahead and check the compression using a compression tester to see if there's any problem internally. This tells you how good the valves and the rings are sealing, and how good the intake valve is operating, letting the airflow in. So to perform this test, all you gotta do is install this tester by threading it into the spark plug threads, and you'll want to crank it for about 5 seconds. When performing this test, you want to disable the ignition so it doesn't start, but with the module and coils removed, I don't have to worry about that. This is a good reading and what you would like to see, and what you'll want to do is get this reading and compare it with the remaining 3 cylinders, and you want them to be about 20% of each other. What I'm starting to lean towards are possible faulty coils. When a coil begins to go bad, it starts with random misfires like in this case. Then eventually the coil completely goes out and you'll have a coil that doesn't fire at all. These are the ignition coils. Here we got a 2-coil design, and each coil fires 2 cylinders. So this coil fires cylinders 2 and 3, while this coil fires cylinders 1 and 4. And this is the ignition module. So what I'm going to do here is test the ignition coils to see if there's possibly a high resistance reading. Since they are operating, there will not be an open circuit, but if you suspect the coil is bad, it is a good way to test for it. We will be focusing on these 3 pins. The middle and on the right will test coils 2 and 3, and testing the middle and the left will test coils 1 and 4. You'll want to have your ohm meter set to 200, and as you can see, these coils are giving a good reading, but since the misfires are random, it doesn't mean that they are not bad. And these are the pins I was referring to, the middle and the ones on the right, and the middle and the ones on the left. This is a scan of a previous video I did of another Cobalt where 2 cylinders were misfiring, and what ended up being the problem for that one was a bad ignition module. And here's the bad ignition module from that Cobalt, and I'm going to show you how you can test it if you suspect a bad ignition module. You're going to want to connect the ignition module to the connector from the vehicle. We're going to need a multimeter, and we're going to want to have it set to 20 volts. And you're going to want to connect the red lead to a battery post, which this car has a battery post right here. And you're going to want to connect the black lead to the coil signal pin on the ignition module. Here's a closer look at the black lead and the pin we are connecting it to. To test the coil signal for cylinders 1 and 4, we want to test the first pin closest to the camera. And you're going to need to have someone crank over the vehicle, and you want to monitor the voltage increase. And since it's not a constant voltage, you won't receive much voltage from it. And now for the side with the misfires. You will notice that we get nothing to register for this side of the module. So I decided to replace the ignition coils, since they are known to be problematic, especially on this vehicle. For a more detailed video on the removal and the install of this ignition coil and module assembly, please check out my other video, which I'll have linked at the end of this video. And this is after installing the new coil assembly. You will notice that the misfires are now gone. I hope you found this video helpful. If you did, please hit that like button. It really helps support my video and my channel. And if you haven't subscribed, please consider subscribing.